This video quick card covers the operation of the T-Bird 6000 or T-Bird 8000 platform with OTDR module. In this case, the demonstration is using a 6000 platform with 1310 nanometer, 1550 nanometer OTDR module. This quick card specifically discusses operation of the OTDR in the fault locator mode. When the T-Bird 6000 is turned on, the last screen presented when the unit was last turned off will be displayed. In this case, the results screen. Press the System hard key, then using the arrow keys, select the OTDR by placing the green box on the OTDR icon. Then press the Enter key in the center of the arrows to activate the OTDR. When the OTDR icon is highlighted in yellow, it is operational. Now press the Setup key and use the arrow keys to select the fault locator function in the Mode menu in the Acquisition box. The three choices are manual, automatic, or fault locator operation. At this point, press Test Auto to set all the fault locator parameters to their defaults. You need not adjust any other fault location parameters. Connect the T-Bird 6000 to the fiber to be tested and then press the blue Start-Stop key. The OTDR will select the 1550 nanometer laser and auto-configure a pulse width appropriate to your span. It will also auto-configure an acquisition time. In this case, we can see that the T-Bird 6000 has selected a 30 nanosecond or 3 meter pulse and a 36-second acquisition time. The red bar graph shows the acquisition in progress. After completing the 1550 nanometer measurement, the trace will be color-coded, it will remain on the screen, and the T-Bird 6000 will switch to the 1310 nanometer laser. Here it's testing the 1310 nanometer laser using a 10 nanosecond pulse and a 20-second acquisition time. The unit then automatically reports the results obtained at 1310 nanometers. We can see that the end of fiber to the reflected break, also indicated by the blue end of fiber icon on the screen, is 4.12 kilofeet away from the operator, or 4,120 feet. The loss at 1310 nanometers from end to end, not including the first and last connector, is about 1.22 dB. We can press the Trace button to switch from the 1310 nanometer display to the 1550 nanometer display. Here we can see that the end of fiber is located at the same position, 4,120 feet, but the end-to-end loss is almost 9 dB, or 8.86 dB. The 1.221 dB shown at the top of the screen is the loss between the A and B cursor and does not necessarily represent the total loss of the span. Looking at the screen at about 4,000 feet, we can see that the active trace, the green trace, 1550 nanometers, has a very large loss event just before the end of the fiber. This would typically indicate a bending problem. We can press the fourth function key, the Table Summary key, to go to the summary screen. On the summary screen, the total loss, total optical return loss, and total length at 1310 and 1550 nanometers is displayed. And also below is the bend table showing the worst 3 bends located in the fiber by comparing differential loss at the 2 wavelengths, with the most significant bending problem shown first, not necessarily the nearest bend. So we can see that there is a bend of about 3.6 dB difference between 1310 and 1550, and the distance to this bend is about 3,900 feet. There's another smaller bend that may or may not be of concern at 0.22 dB at about 942 feet. This concludes operation of the T-Bird 6000 in the fault locator mode.